Hey guys, today we're working on Unit 4, Lesson 4, which is similar triangles. And the same rules for triangles apply to all polygons, okay? So let's take a look at some of these basic rules. All right, polygons are the same shape, but different sizes. That is what similar means, okay? They are similar if the corresponding angles are congruent. Remember, congruent is another way for saying equal. And the corresponding sides are proportional. So proportional, meaning that their ratios are equal to one another. So don't forget, just a review of some older vocabulary, the ratio of corresponding sides is called the scale factor. And if polygons are similar, then the perimeters are also proportional. So I have an example down here that I have it's already on your guided notes, but I color coded, okay? So I have an orange triangle and a blue triangle. I want you to note that the markings in the angles are already showing that like angle A is congruent to angle D. Angle B is congruent to angle E, and angle C is congruent to angle F. They've already given me that information. And then what they did was they gave me the side measures for each triangle. So we're going to take a look at if the sides are proportional, and also if these are proportional and similar, then their perimeters must also be proportional. So what I did was I went ahead and I added up 8 and 10 and 14 here to get the perimeter of 32. And then I added 12, 15, and 21 from the blue triangle to get my perimeter of 48. Okay. All right. So let's take a look at how we write the scale factor of ABC to DEF. So I'm just going to pick one of the sides of the triangle. So I chose 8 and 12. I know that 8 and 12 are the ones that go together because they're both between angles 1 and 2. Angles 1 and 2. And another way to see it is that in the written statement here, A and B are the first two letters, and D and E are the first two letters. They're in the same order in the statement as well. Okay, so here's what I get. I get ABC to DEF is going to be 8 to 12. Another way to say 8 to 12 is 8 over 12. 8 over 12. And if you reduce that, you're going to get 2/3. So the ratio of orange to blue is 2 to 3. Let's take a look and see if it's the same if we write it the other way around. What is the scale factor of DEF? So I'm using the same sides. So D and F, this is now blue, or D and E, I mean, blue to orange. Blue to orange. So in this situation, I'm going to end up having blue to orange is going to be the same as 12 to 8, which is written like this, 12 over 8. Okay, and then if you reduce that, you're going to get 3 to 2. So in this sidebar over here, it says order matters. So whatever triangle they give you first has to go on top, those numbers, okay? Okay, because it won't give you the same results. All right, so now that we have the proportion from one side to the next side, let's check the proportion of the perimeter of triangle DEF to ABC. So again, DEF is blue, ABC is orange. So we're going to have 48 over 32. 48 over 32. And so if you simplify 48 over 32, you're going to get 3 over 2 or 3 to 2 ratio. And I want you to notice that these are the same. The perimeter is the same as the ratios of one set of corresponding sides, which means that all of the other sides will also be proportional. So 15 over 10 will reduce to 3 over 2. 21 over 14 will also reduce to 3 over 2. Okay, let's take a look at a similarity statement here. So these two triangles up above, ABC and DEF, we're going to write a similarity statement for them now. Okay, so a similarity statement is different than a congruency statement. This is what we've been using in the past, was congruent triangles. Now we're going to use this symbol for similar. Notice the only thing it's missing is the equal sign underneath it, because similar triangles do not have all equal parts. They have some equal parts and some proportional parts. So we just need to include this symbol right here. They are similar. Okay. And so I'm now going to give you a different set of triangles. And I want you to list all the congruent angles and write a proportion that relates the corresponding sides. So what I've gone ahead and done is I color coded. So the first letter in each statement, those are the two angles that they're saying line up to one another. So J is red and P is red. K is blue and it's a second angle, so I put 2 lines. And M is also in the middle, so M is blue. And then the last letter in each statement is L and N. So those two angles are corresponding. And so these ones are pretty simple to write. Starting with red, I can do angle angle J is congruent to, well, I can't say congruent, can I? Yeah, they're congruent. The angles are congruent, okay, to angle P. And how do I know for sure? List all congruent angles and write a proportion that relates the corresponding sides, okay? All right, angle K is congruent to angle M. And now this is harder to tell. This is green I used. Angle L is congruent to angle N. All right, now for the sides, you do see these colored dots that correspond with red, blue, and green. Okay, so for side, red to blue, that is going to be JK. And that's going to correspond to the other triangle. Again, I need to put them in the proper order. So it has to start at red and go to blue. So that's going to be PM, side PM. Okay, now we're writing equals because we're writing a proportion. So when I do a proportion, I use an equal sign. All right, so now let's do blue to green, side blue to green. And I have to start with the first triangle that they gave me on top. So Blue is K, green is L. So side KL, and then blue to green is MN. And now I'm ready to go all the way around the circle. So green to red is LJ, and green to red is NP. And that is my proportion, okay? That relates all three sides of my triangle. And that's what we're going to be writing to solve problems today, are proportions like this. Three-way proportions. Alrighty. So now that we have a basic understanding of congruent angles and proportional sides, let's look at an example. Okay, so if triangle PQR is similar to triangle UTV, find the value of X. So since they gave me PQR first, that's going to have to go on top, okay? And so if you want help to remember how to set up the proportion, whatever they give you first is top, whatever they give you second is bottom. That's kind of how I do it. Okay, so QR is 8. So QR is going to be 8. TV, how do I know T and V? Well, Q and R are next to each other here. T and V are next to each other in the same locations in the other statement. So TV is X minus 3. X minus 3. Okay, now let's do RP, which is 14, to VU, which is X plus 6. X plus 6. Let me scooch this down for you and zoom out a tiny bit. Okay. So I've set this up. And now I'm going to do it just like I've done it in the past. We are going to cross multiply. Okay, so X minus 3 times 14. I just switched this around so that the 14 is in the front because that's what I'm going to be distributing. And then, and for some people, it does help to draw the little circles. Okay, so that's my orange side. And I guess this will be my teal multiplication. So I'm going to get 8 times X plus 6, and those are going to be equal. All right, now let's go ahead and solve. 8 times X, 8 times 6, 14 times X, 14 times negative 3, that is 42. Negative 42. Okay, I'm going to subtract 8x from both sides. 14 minus 8 is 6. Let's go ahead and add 42 to both sides. And I get 90. So divide by 6. What is 90 divided by 6? I'm going to cheat really quick. I get 15. Okay, so they just wanted me to find the value of x. So x equals 15. If for some reason they had asked me to find the length of one of these sides, VU or TV, all I would do is plug these in. So 15 minus 3 would be side, this is 12. And 15 plus 6, this side would be 21. Okay, 21. And that is how I use, okay, similar triangles to solve a problem. All right, similar triangles. Let's get into specific types of similar triangles. There are 3 types of triangle similarities, okay? So these are going to be kind of reminding you of some of our congruency statements. Like we had a side, side, side. Actually, yeah, we did a side, side, side congruency. We also had a side, angle, side congruency. But we can also have similarity statements if we don't quite have exactly enough information, or if the side lengths are not congruent, but they're proportional. That's when we can use these, okay? And then now, remember, we could never have an angle, angle, angle congruency. And we did discuss that just because 3 angle measures of a triangle might be congruent doesn't necessarily mean that the side lengths will be. So we couldn't write a congruency statement, but now we will be able to write a similarity statement. So let's look at the examples for angle, angle similarity. If 2 corresponding angles are congruent, then the triangles are similar. All you need is 2 angles because we know that the 3 measures of every triangle add up to equal 180 degrees. So if 2 of them are equal, then the third one will also be. So let's take a look at example 1. Okay, I have a 75-degree angle and a 75-degree angle. So those are congruent. And I have a 31-degree angle and a 31-degree angle. Okay, so these are definitely congruent. We just need to write, if yes, write a similarity statement. Okay, so here's our similarity statement. So we said yes. Okay, triangle ABC, so orange, blank, red, is going to be congruent to DEF. They have to go in the same order. Orange, blank, red. Orange, blank, red. So DEF. All right. Let's look at example number 2. For example 2, they only listed one set of angles for me. They listed V and Y. Okay, V and Y. Is there another pair of angles that I know in this situation are congruent? Okay, I know that angle X is congruent to angle X. How do I know this? So just a vocabulary check. These are vertical angles. And vertical angles, we learned, are congruent angles. Okay, so yes, these 2 triangles are similar. Okay, now let's make sure that we write the statement correctly. Okay, so you could say red blank orange, red blank orange. You have to just be careful that you write it the correct way. Okay, so in this case, let me just start out with the blank side. Go to orange, go to red. So WVX is similar to, again, I'm going to do blank, orange, red. Okay, and so they both ended with X because that's the red angles that match up. So color coding can totally help you here. All right, let's take a look at some examples for our side similarity. If all corresponding sides. So let me come here and highlight if two corresponding angles. So that's two corresponding angles. This is going to be all corresponding sides. And then notice the differences in the words proportional and congruent. Okay, angles are congruent, sides are proportional. Okay. All right, so determine if the examples below are similar by side, side, side. So let's take a look at this. So in this case, they don't have any angles or anything marked. So I need to just kind of say, let's look at it this way, okay? 3 to 6. I'm going to use a different color. So orange and red. So I'm doing the 3 first. It didn't tell me which way to do this. I could do 6 over 3. That's fine. As long as I got to choose big to little. I'm sorry, little to big or big to little. But all we're trying to do is determine if they're similar. So it doesn't matter which one you do first in this case. Okay. Next, I will have 5 to 10. 5 to 10. And the third side is going to be 4 to 8. So can I say that all 3 of these ratios are equal? Well, 3 over 6 is 1/2. 5 over 10 is 1/2. 4 over 8 is 1/2. So these are all equal to 1/2. And if they wanted me to find the scale factor, that's what it is, okay? They all have the same scale factor. So they're definitely proportional. So yes. Okay. Let's take a look at example number 4. So I'm going to leave 3 up there so we can look at it. All right, let's do the same thing again. So I'm going to do this time the big triangle on top and the little triangle on bottom. So 24. Okay. So big on top. So let me go ahead and work my way around the big one. 30, 35, 32. And then around the little one. So went around the right, 24, 28, 25. Okay. So are these going to be equal to one another? Well, I could use my calculator if I wanted to. 30 over 24. Now those both do reduce by 6, so I would have 5 over 4. 5 over 4. Both of these are able to be simplified by 7. So 35 divided by 7 is 5. 28 divided by 7 is 4. What about 32 over 25? 32 is divisible by 4 and 8, but 25 is only divisible by 5. Okay, so here's my problem here. Here's my problem. These two sides are congruent, but this third side does not match up with the other two. Okay, so you could reduce your fractions, or another way that you could also do it is just type them in the calculator and compare their decimal values. So like 30 over 24 is 1.25. 35 divided by 28 is 1.25. And then 32 divided by 25 is 1.28. It's different, okay? So the answer to this is no. No, these are not similar to one another, okay? So sometimes you do have to check all three because there might just be one that doesn't belong, okay? All right, and then let's do our last set of similarity. If two corresponding sides are proportional and the included angles are congruent. Okay, remember the included angle is the angle that falls in between the two sides. So it has to be included. It is an included angle, okay? All right, so here's what we're going to do for this. We are going to take the two sides that we know, okay, 8 and 6. So 8 over 6 and 20 and 15. In this case, I did big on top, little on bottom, so big to little. And 8 over 6 and 20 to 15. Do these give me the same value? Okay. Well, the simplest way to do this is to just do it in your calculator. 8 divided by 6 is 1.3 repeating. 20 divided by 15 is also 1 over 3 repeating. So those are equal, okay? If you don't have a calculator handy when you're doing this, another way that you could check is like by going all the way back to, I'm not sure when you learned this, maybe elementary school, when your teacher would say, check if these are equal. So you could do 6 times 20, which is 120. And then you could do 8 times 15, which is also 120. So if you check their cross products, that is another way, okay? And so, yes. All right, let's take a look at number 6. These triangles actually don't have any angle identified for me. So when you see a triangle like this, you really need to think about it. Where is the included angle? Well, they share angle A. And I know that angle A is congruent. A is congruent to A, okay, by the reflexive property. It's always congruent to itself, okay? So that's my included angle. Now let's set up our proportions. So it doesn't matter how you do it, big to little or little to big, it should work out to be the same. So let's just do, I guess 21 is the big to 25. Oh, wait, I'm sorry, 21 to 12. 21 to 12 is how I want to write that. Oh, no. 21 over 12, 25 over 15. Okay. And so you can either cross multiply, you can type them in the calculator and check their decimals, or you can reduce the fractions. So 21 and 12 are both divisible by 3. That would give me 7/4. And then these are divisible by 5. That would give me 5/3. Well, 7/4 is not equal to 5/3. Okay, so this is no. So we saw some examples of yeses and some examples of nos. Here's what I want you to do. There are 4 more examples at the bottom of your paper, and I want you to briefly take a minute. So I'm just going to show, I guess, examples 1 and 3 first. And I want you to not only determine if they're similar or not, but identify how, okay? Because these are all mixed together. So if they are similar, write a similarity statement using angle, angle, side, 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 or side, angle, side similarity statements. Okay, so let's do 1 and 3 first. So pause your video and complete 1 and 3. All right, guys, so here is my example 1 and my example 3. Now, how did I know to put 45 with 31.5 and 50 with 35? So I do have a big triangle and a little triangle, but in each triangle, there is a bigger side and a littler side, a bigger side length and a littler side length. So the 2 smaller side lengths, if they're going to be proportional, those are going to be the ones that work. And then 50 and 35 are the 2 larger numbers. So those go together, okay? So now, if I just check these in my calculator, 45 divided by 31.5 gives me 1.4. And let's check and see if that's equal to 50 divided by 35. And that also gives me 1.4. So yes, these are similar, okay? But how are they similar? So I have a side, an angle, and a side. And then again, a orange side, an interior angle, and then a blue side. So let's write our similarity statement, okay? So triangle, let's do the blue side first. F to G, F to G, that's the blue side, and then the orange side is G to E. So I did blue to orange is similar. So now I need to start with blue to orange the same way. So K to H is blue, and then H to J is orange. And that's my similarity statement. All right, let's take a look at example 3. I did a little bit of work here, but I haven't written a statement yet. So they gave me a right angle in both triangles, a right angle. This angle, they gave me 39. This angle was 51. Well, I needed to choose one of these triangles. Okay, so 39 plus 90 plus x equals 180. Okay, 9, 10, 11, 12. That's 129 plus x. And then 180 minus 129 is 51. So what that meant was that the missing angle in this triangle was 51. So that's congruent with this angle here. Okay. And if I did this again, I would get 39 and 39 here. Okay. So I do have 3 angles in each triangle that are the same measure. And I color coded them. 39 is orange, 51 is red, the 90-degree angles are blue. So now let's write our similarity statement. Oh, up here I forgot to say why. These are congruent with side angle side, or not congruent, similar, side angle side. So these ones are also similar, but let's write our statement. So triangle, so I have a triangle going to be similar to another triangle using the angle, okay? So you can really kind of set this up however you want. I'm going to go orange to red, so E to S, and then red to blue, which is S to Y. Okay, let's do that again. Orange to red, so H to W, and then W to C. Okay, and notice that the colors match up. Okay, angle C and angle Y are the 90-degree angles, and they both come last. Okay, W is the red angle, S is the red angle, and then of course E and H are both the orange angles. So if you color code, it should help you write these statements more accurately. All right, go ahead and pause again, and I'd like for you to complete examples 2 and 4, again using the same rules. So go ahead and pause your video while you work on examples 2 and 4. Hey guys, welcome back. I completed both examples 2 and 4, okay? Now, for example 2, you could have checked this in 2 different ways. I went ahead and checked it by side, side, side. So I checked all 3 sets of sides. Now, what was tricky about this large triangle is that you had to add 12 and 8 to get their total length of 20. Okay? So 8 to 20, 6 to 16. You can check right here that 0.4 is not equal to 0.375. And I could have just done those 2 right there and stopped, because this is an angle side angle possibility because A is congruent to itself. I chose to just double check with side, side, side. So I included this third side, 9 to 24. And 9 to 24 is 0.375, which does match up with one of the other sides, but not both of the other sides. So this is a no, and it did have the potential to be solved using side, 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 or side angle side similarity. In example 4, my only option was the side angle side similarity, okay? And so remember, 36 is the smaller number in this triangle. 20 is the smaller number in this triangle. It doesn't matter how you set these up, okay? And then 42 is the larger, 24 is the larger. So I put this triangle on top and this triangle on bottom when I did my proportion, okay? All right, guys. And then, of course, I used my calculator, and 1.8 is not equal to 1.75. It's really close, but not equal. So that is our lesson for today. Triangle similarity. This is most closely related to congruent triangles. There are a lot of proofs that go with triangle similarity. We're not going to cover 2-column proofs with similarities, okay? But just know that that is possible, again, using all the things that we've learned about, vertical angles, supplementary, complementary, all those vocabulary phrases that we've been learning over the last few units. Okay, so that was today's lesson 4-4. Be sure to get your practice on, and until next time.